Hello, this is a tutorial or a video cast that talks about naming hydrocarbons. To name something is called nomenclature. And here you can see a little hydrocarbon baby with a ring sort of structure. It looks like it happens to be benzene, actually, being named. I apologize for any religious affiliation that this slide has. This is not mine. I took it from someplace else. So, just to review, we can have two types of hydrocarbons. One type is called saturated, which includes alkanes and cycloalkanes. Alkanes are hydrocarbon chains that contain all single covalent bonds. Each of these carbon atoms would be surrounded by hydrogens, and a cycloalkane is a cyclical structure in which the carbons are enclosed in a circle. The unsaturated hydrocarbons include alkenes, which contain carbon chains with one or more double bonds, and cycloalkanes, which contain enclosed carbon chains with one or more double bonds, and also alkynes, which are carbon chains in which between two carbon atoms there will be one or more triple bonds. So when we're drawing structures, I'm just going to get everything up on the slide here that should be here so I can use my pen properly. So when we're drawing structures, this is an alkene. It happens to be called 2-butene. This is a full structure. We can take this and we can turn it into a condensed structure. Sometimes you will see the condensed structure with dashes in between the element symbols, and sometimes you won't. In this one, you see that this end here could be drawn as a CH3, but they drew the C here and they put the H3 here just as a reminder that it's carbons that are being bonded to one another. And this could also be drawn like this: CH3, CH, CH, CH3. It could be drawn like this with ziggy-zaggy pattern, and there should be dashes going to these hydrogens. Here the hydrogens are included. Here we have some lines represented with the CH3s on each end, and here it's just the lines indicating that we have 1, 2, 3, 4 carbons, and in between the second and third carbon there is a double bond. Now this is a PowerPoint taken from someplace else, so on a test here it says choose a method that shows all hydrogens. I will specifically ask you what I want or what I expect from you on a test, so I will always specifically ask you what it is that I'm looking for. So sometimes you can have a condensed formula that's really, really long. We've got a lot of carbons here. 1, 2, 3, 4, 5, 6 carbons here. And rather than the redundancy of writing this each time, that all of those CH2 groups could be put in parentheses indicating there are 4 with a CH3 on each end. So that's like a condensed form. You will not commonly see me do this, but I may from time to time. Okay, so when we're naming hydrocarbons, first we have to indicate what type it is. Is it an alkane, an alkene, a cycloalkane? Is it an alkyne? Is it an aromatic compound? It has a benzene ring. we have to look at how many total carbons there are, if there are any side chains. The name is always going to end in ane, ene, or eine. Alkanes will end in ane, alkenes will end in ene, and alkynes will end in eine. The number of carbons is always represented by a prefix. And here are those prefixes. 1 is meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 is dec. And in actuality, it should be like metha, hexa, but these prefixes are all used in names where it would be up next to a vowel, and it makes it kind of awkward. So here's a question: what names would be given to each of these? Here we have a 7-carbon alkane would be heptane, and a 9-carbon alkane would be nonane. A 2-carbon alkyne would be 2-ethine, and a 4-carbon alkyne would be butine. A 1-carbon alkene and a 3-carbon alkene. If we use the same patterns, you'll see that 1 is meth, but this is designed to trick you because an alkene by definition is a substance in which there is a double bond, at least one double bond between 2 carbons. So it's not even possible to have a 1-carbon alkene. So that is impossible. The only 1-carbon substance we can have is an alkane, which would be methane. And that would look like this. 1 carbon surrounded by hydrogens. Methane. There is no such thing as a methene or a methine. And that's why that's crossed off. So, a way that we can remember the first 4 prefixes is this mnemonic device, and it is that monkeys eat peeled bananas. Monkeys eat peeled bananas. First is meth, 1, eth, 2, 3 is prop, and 4 is but. Now, quite honestly, these are the 4 prefixes that you will use the most, for sure. Here are the other prefix. Pent is easy for us, associated with the pentagon. Octopus has 8 legs, or 8 carbons. Oct is 8. Dec is 10. Just like a decade has 10 years, a decimal is based on a system of tens. And a decathlon is a race that is maybe 10 miles or maybe 10 kilometers. I don't know. And there are the rest. All right. So whenever we are looking at a carbon chain or a carbon ring, we have to number the carbons. And the question is, how do you know how to number them? So here I have a carbon chain, and there are 1, 2, 3, 4, 5 carbons in the carbon chain. And carbon chains have numbers. We have to number the carbons for naming purposes. So it might make sense to just say, well, we're always going to start with the one that's closest to the left, because like when we're reading a book, we start at the left and move to the right. So if we were to do that, this would be the number 1 carbon, this would be the number 2, this would be the number 3, this would be number 4, and that would be the number 5 carbon. And the reason we have to number carbons is because sometimes we have branches, and when we're naming hydrocarbons, we have to indicate in the name which branch the carbon is on. In this case, we have to indicate where the double bond is. So here, the question says draw one pentene. If our sorry about that, carbons were numbered like this, my double bond would need to be here and not here because it said to draw one pentene. Now, is this drawn incorrectly as one pentene? It's not. In actuality, oh, I thought my colors would go away, but they didn't. Oh, goodness gracious. I feel like they're never going away. I don't know how to make them go away. Oh, well, it might stay there forever and ever. Just please be patient with me. I'm going to end the show and then restart this one because those little blurbs on there make me unhappy. Okay, so if we start numbering from the other side, 1, 2, 3, 4, 5, then this does become one pentene. So if you have a carbon chain and there is a double bond in it, when we start numbering our carbon chain, which is something that we will always have to do, you want to look to the end that's closest to the nearest double bond. So naming compounds with multiple bonds is complex. When there's more than one possibility, we need to use numbers, and we always will give the double bond to the lowest number. So, for example, here we have a 4-carbon chain, and I am identifying here that it's an alkene, so it has to end in -ene. That makes this butene. Now I have to indicate which carbon the double bond is on. And if I start counting from this side, 1, 2, oh, this is on the second carbon. Let me try from the other side. 1, 2. Okay, it's the same no matter what. 2 butene. So looking at this one, we have a total of, counting the carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. And these are all single bonds here, except for this. We see the 3 lines that represents a triple bond. That makes this an alkyne. That's horrible spelling. Now, which carbon is it on? It is on the 3rd carbon, so that makes this 3-nonine. If I draw this one out, I can see that it is an alkene, and with 2 carbons, that would make this ethene. Okay, if we have side chains, the side chains are going to have names, or the branches are going to have names. This here is 2,2-dimethylpentane. Now let's just look at this for a second. I'm going to activate the pen. Here we have 1, 2, 3, 4, a 5-carbon chain, and they're all single bonds, which makes this a pentane. Here we have a branch, and that branch has 1 carbon in. If a branch has 1 carbon in, it is called a methyl group. If the branch were to have 2 carbons in it, it'd be called an ethyl group. 3 carbons would be called a propyl group. So when we're looking at this, we look for our longest chain. That's pentane. All right, I'm going to circle that. Longest chain has 5 carbons. Now I have to count these carbons. And I don't have any double bonds here, so the question is, what strategy do I use now to start counting from which side? I want my branches to have the lowest numbers. So the branches are closest to this end, so I'm going to start counting from this side. My number 1 carbon, my number 2 carbon. So in this spot right here, that bend represents a carbon, this represents a carbon, this represents a carbon. Here's my number 3, my number 4, and my number 5. Okay? So I have a methyl group on my number 2 carbon, and I have a methyl group on my number 3 carbon. So if we look at the name here, 2, 3 dimethylpentane, the 2 and the 3 are indicating which carbons the methyl groups are on. Since we have 2 of the same group, we use a prefix to indicate that there are 2 of them, 2, 3 dimethylpentane. So these are the rules. We have to figure out what it is and choose the correct ending. We have to find the longest chain. When there's a double or a triple bond present, we're going to choose the longest chain that includes that bond. If there is a cyclic structure present, the longest chain starts and stops within the cycle. We have to assign numbers. For alkenes and alkynes, the first carbon of the multiple bond should have the smallest number. If it's an alkane, the first branch should have the lowest number. We have to attach a prefix that corresponds to the number of carbons in the parent chain. If it is a cyclic structure, we add cyclo. I know I'm going through these rules very, very fast, and I'll just repeat them as we go through each example. If there are any branches, we have to make sure that they're given the correct names. We're going to attach the name of the branches alphabetically, along with their carbon position, to the front of the parent chain name. So, for example, if there's an ethyl group and a methyl group present, we write the ethyl group in the name first because E comes before M. When 2 or more branches are identical, we use prefixes, di or tri, etc. We don't take prefixes into account when we're determining alphabetical order. For example, I'm just going to draw this out. We have 2, 3, 5 trimethyl, 4 propylheptane. Ooh, that's a big one. I'll just start drawing some C's here. Heptane, we'll work backwards. Heptane. It's an alkane. It has all single bonds. There are 7 carbons. 1, 2, 3, 4, 5, 6, 7. If this is my number 1 carbon and this is my number 7 carbon, sorry about that. On the second carbon, I have a methyl group, which contains 1 carbon. On the third carbon, I have a methyl group. And on the 5th carbon, I have a methyl group. On the 4th carbon, I have a propyl group. Alright, so each of my methyl groups has 1 carbon, and my propyl group has 3 carbons. propyl, methyl, methyl, methyl. So we have 3 methyl groups, and that is why we see the word tri in this name, the prefix tri in this name. And M comes before P, and it doesn't matter that the prefix has T in it, so we're not looking at the fact that P comes before T. In this case, we're still looking at the M in the name methyl to indicate the order. If you do have 2 groups on the same carbon, you have to write the number twice. Okay, let's look at this one right here. So, find the longest continuous chain. If there is a double or a triple bond present, the longest continuous chain must contain the double bond or the triple bond. Here we have a double bond. So at first, excuse me, I'm so tired. I'm coughing. I'm tired. I'm yawning. Please, I'm not going to have time to edit this. It's rough. I'm sorry. If I look for the longest chain, 1, 2, 3, 4, 5, 6, 7, I say, oh, there's 7 carbons there. That's the longest chain. But this is where you have to try not to be fooled. In this case, the longest chain must include the double bond. So my longest chain has to include the double bond is going to be, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. All right, my longest chain is bending around like this, and it contains 6 carbons. Now I need to number my carbons. Again, if a double bond is present, we want the double bond to have the lowest number, which makes this my number 1 carbon. This is my 2, 3, 4, 5, 6. All right. So that makes this an alkene with the double bond on the first carbon. The parent chain is going to be 1-hexene. Now let's look at the groups that exist. On this second carbon, I have a branch. This branch is on the second carbon, and it has 2 carbons, so it is an ethyl group. So I have a 2-ethyl. Okay. On this number 4 carbon, I have a methyl group, and also attached to the number 4 carbon is a methyl group. So I have 4-methyl, 4-methyl. Okay, so when I'm putting the name together, I have to name the group that is lowest in the alphabet first, and it happens to be my ethyl. Since I have 2 methyl groups, I could say 2-ethyl, 4-methyl, 4-methyl, 1-hexene, but they're the same, so I'm going to combine them. The name of this is 2-ethyl dash 4, 4 dimethyl 1-hexene. That is a big name. And this is just bringing it through the process. Choosing the correct ending. It's an ene. Determining the longest chain. And assigning numbers. Makes that 1-hexene. Determining the name for the side chains. I have an ethyl group there, and a methyl and a methyl. Attaching the branches alphabetically, and here you see that originally they have it all They have them written separately, but grouping similar branches turns it into that dimethyl. 2-ethyl-4,4-dimethyl-1-hexene. Now if I were naming this, I would not say the dashes and the commas. I would say 2-ethyl, 4,4-dimethyl, 1-hexene. That is the name of this substance. So let's look at this, and it's giving me the name, so I'm just going to draw it. Propene, okay, prop. The prefix for prop stands for 3. So I have 3 carbons, and it's ene, so I know there's at least one double bond. Now I'm just going to add my hydrogens. I know there's only going to be 2 hydrogens on this one because this carbon can only have 4 bonds around it. 1, 2, 3, 4. This is a double bond, so 4 dashes around it. This carbon's only going to have 1 hydrogen because this carbon has 2, 4, 6, 8 electrons around it, or 4 dashes. And this end one will have 3 carbons. Now, I could have put the double bond there. I absolutely could have. When I look at the condensed formula for this, it would look like this: CH2, CH, CH3. And I think when they draw it, they actually draw it the opposite way. They put the double bond there. Alright, 2-butene. Alright, I know I have an alkene. Whoops. I have to activate my pen again. 1, 2, 3, 4. I am going to have my double bond on the second carbon. And if I were to add all of my hydrogens, this would have 3 hydrogens. Each of these would only have 1 hydrogen, and this would have 3 hydrogens. The condensed structure would then look like this: 2,4-dimethyl-2-pentene. Alright, 5 carbons, pentene. 1, 2, 3, 4, 5. And it says it's 2-pentene, so the double bond is going to go on the second carbon. I have 2 methyl groups. One is going to be on the second carbon. 1, 2, 3, and 1 methyl group will be on the fourth carbon. So if I add my hydrogens, I have a CH3, CH3, CH3. This will not have any H's because I have 2, 4, 6, 8 electrons around it. CH, CH, CH3. And they put their double bond on the second carbon from this end. Either way is just fine. 1-butyne. Bute, 4 carbons. 1, 2, 3, 4. Butyne means it's an alkyne and it's attached to the first one. So if I put my hydrogens on, each carbon needs to have 4 lines around it representing shared electron pairs. This carbon 1, 2, 3, 4, 1, 2, 3, 4. The condensed formula for this would be CH, triple bond, C, CH2, CH3. And there we go. All right, the next step is naming these, finding the longest carbon chain. This is an alkene, so it must contain the double bond. 1, 2, 3, 4, 5. All right. This is my longest chain. I'm going to number, starting at the end that has the double bond closest to it. 1, 2, 3, 4, 5. Here I have a methyl group attached to the third carbon, so I'm just going to write 3-methyl. Here I have a methyl group attached also to the third carbon, 3-methyl. Alright, so as I name this, 3, 3, dimethyl, 1, pentene. Okay, looking for the longest chain here that contains the double bond. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. This is my longest chain. And I'm going to number them. 1, 2, 3, 4, 5. On the third carbon here I have a methyl group, which makes this 3-methyl. On the third carbon here I have a methyl group, which makes this 3-methyl. And the name of this, 3, 3, dimethyl, 1, pentene. And as you can see, it's the same as this. They're the same, just drawn two different ways. Alright, on this one, looking for the longest chain, this is an alkyne. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Alright, both of them are 7. So I am just going to circle. That'll give me the same thing. I'll circle that as my longest chain. I'll number. The triple bond is here, so I'm going to start from this end. 2, 3, 4, 5, 6, 7. On my fourth carbon, I have a methyl group. That makes this a 4-methyl. On my fifth carbon, I have an ethyl group. Makes this 5-ethyl. So naming this, ethyl comes first, 5-ethyl, 4-methyl, 2, second carbon. The prefix for 7 is heptine, 2-heptine. And that concludes this tutorial. So where is it?